Good day, students. Welcome to Earth and Life Science Remediation Program. Currently, you are on week 1, lesson 4 of this program. Today, you will be able to describe where the Earth's internal heat comes from and describe the changes in mineral components and texture of rocks due to changes in pressure and temperature, or metamorphism. Before we begin the discussion, may we remind you to take photos of yourself while watching this video and while taking notes. Your photo collage and your notes will serve as your attendance for today. Now that you are ready, let's begin. In our previous discussion, you were able to identify common rock-forming minerals using their physical and chemical properties and classify rocks into igneous, sedimentary, and metamorphic. Natutunan ninyo na ang igneous rocks ay mula sa nag-solidify na magma o lava na lumalabas sa volcano. Ang magma o lava na lumalabas sa volcano ay nagbibigay sa atin ng clue kung gaano kainit sa loob ng Earth. Bakit nga ba mainit sa loob ng Earth at ano ang nagpapainit dito? Kung ang igneous rock ay mula sa nag-solidify na magma o lava, paano naman nabubuo ang metamorphic rock sa pamamagitan ng extreme heat at pressure? Aalamin natin ang mga yan sa lesson natin sa araw na ito. Pero bago tayo pumunta sa ating lesson, let's test first the sharpness of your memory by trying this activity. All you have to do is to label the layers of the Earth correctly in 2 minutes. You have to get a piece of paper and write the letter of your answer based on the choices given. The timer starts now. Time is up. Tingnan natin kung tama ang mga sagot nyo. Let's check your answers. Number 1 is the crust. Number 2 is the rigid upper mantle. Kung matatandaan natin, crust at rigid upper mantle ay tinatawag na lithosphere. Number 3 is the asthenosphere. Number 4 is the lower mantle. Number 5 is the outer core. And number 6 is the inner core. What's your score? If you got 5 to 6 points, pat yourself on the back and tell yourself you're brilliant. If you got 3 to 4 points, don't worry, we can learn from our mistakes. If you got 0 to 2 points, it's okay. You can read more about the Earth's layers after this lesson. Just like what I mentioned earlier, An erupting volcano gives us a clue about how hot the Earth is inside. Let's explore the two reasons for the Earth's internal heat. The figure here shows temperature of each layer of the Earth. Mapapansin natin na habang papunta sa core ng Earth, tumataas ang temperature. Ganito kainit sa loob ng Earth kung kaya kapag sumasabog ang bulkan, hot molten rocks or mainit at tunaw na bato ang inilalabas nito. Earth's total internal heat is estimated to 44.2 trillion watts. Approximately half of it comes from the heat left from the early formation of the Earth, and half comes from radioactivity. This means that the Earth's internal heat source has two categories. One is the primordial heat, or the heat from the accretion and bombardment of the Earth during its early stages of formation. Another is the radioactive heat, or the heat generated by long-term radioactive decay. Unahin nating pag-usapan ang primordial heat. Ang term na primordial ay nanggaling sa salitang Latin na primordialis, meaning beginning. Tinawag itong primordial heat dahil ang init na ito ay mula pa noong early formation ng Earth. Nabuo ang Earth sa pamamagitan ng pagbabanggaan ng mga planetesimals o tinatawag na baby planets, noong nagsisimula pa lamang mag-exist ang solar system. This is a violent process of countless collisions of these planetesimals. Sa bawat pagbabanggaan o bombardment, ang kinetic energy ay na-convert sa heat. Habang nabubuo at papalaki ng papalaki ang Earth, mabilis din na tumataas ang temperature nito. Isa sa mga halimbawa ng situation na nagiging heat ang kinetic energy ay kapag nagpupukpok tayo ng pako gamit ang martilyo. Kapag hinawakan mo ang pako pagkatapos ng tuloy-tuloy na pagpukpok, mararamdaman mo na uminit ito. Ganito din ang nangyari sa banggaan ng mga planetesimals o bombardment. Habang nabubuo rin ang Earth, lumalakas din ang gravitational force of attraction nito. Accretion ang tawag sa process kung saan hinihila ng gravity ang smaller particles papunta sa larger object. This figure shows how planets, including Earth, were formed billions of years ago through accretion. The second source of the Earth's internal heat is the radioactive heat. Ito yung heat na nanggagaling sa mga elements na nag-undergo ng radioactive decay. Four radioactive isotopes inside Earth account for about 50% of Earth's internal heat. And these are uranium-238, uranium-235, thorium-232, and potassium-40. Ano nga ba ang radioactive decay? Ang radioactive decay ay ang pagbabago ng isang unstable na parent element or isotope para siya ay maging stable. Sa kanyang pagbabago, maglalabas o magre-release ito ng particles at radiation. Kapag naglabas ito ng particles, ang parent isotope ay magiging daughter isotope. Ang radiation na nire-release ng isang unstable parent isotope ang pinagmumula ng radioactive heat. Kung nagbabago pala ang parent isotope kapag ito ay nagde-decay, bakit hindi nauubos ito sa loob ng Earth? Half-life ang sagot sa tanong na yan. At half-life ang ginagamit na term para i-describe kung ilang taon, araw, or oras ang lilipas bago mag-radioactive decay ang kalahati ng amount ng isang radioactive element. Halimbawa, ang uranium-238, ang half-life nito ay 4.5 billion years. Ibig sabihin, aabot ng 4.5 billion years bago mangalahati ang dami ng uranium-238 sa loob ng Earth. Napakatagal, di ba? Kung kaya't patuloy na nagpapainit ang radioactive decay na ito sa loob ng Earth. Sa figure na ito, pinapakita ang uranium-238 ay merong 12 atoms. Pero pagkatapos ng 4.5 billion years or isang half-life ng uranium-238, ang kalahati nito ay magiging thorium-234 dahil yon ang panahon para siya ay mag-decay at maging thorium-234. Kung mapapansin nyo, kalahati nito ay kulay yellow na o nagbago na at naging thorium-234. Yan ang tinatawag natin na half-life. Paano nagpo-flow ang internal heat ng Earth? Para mas maunawaan natin, balikan natin ang lesson tungkol sa three types of heat transfer. Ang three types of heat transfer ay conduction, convection, and radiation. Conduction is the transfer of heat between two objects that are in direct and physical contact. Katulad ng nasa picture, lumipat ang heat galing sa hawakan ng pan papunta sa kamay. Nag-transfer ang heat dahil sa pagkakaroon ng contact o pagdidikit ng kamay at ng hawakan ng pan. Convection is the transfer of heat from one place to another due to the movement of fluid. A fluid can be liquid or gas. Sa picture na to, makikita natin na nagtatransfer ang heat dahil sa paggalaw ng liquid na nainitan sa ilalim ng container. Umaakit ang nainitan na liquid at bababa naman ang mas malamig na liquid. Sa convection, ang dapat tandaan na phrase ay hot fluid rises, cold fluid sinks. Umaakyat ang mainit na fluid, bababa naman ang malamig na fluid. Radiation is the transfer of heat through electromagnetic waves through space. In radiation, heat still transfers even without the medium. Sa picture na ito, makikita natin na malayo man ang kamay sa heat source, nagtatransfer pa rin ang heat sa kamay. So kahit walang contact between the two objects, heat can still transfer. Paano nagtatransfer ang heat sa loob ng Earth? Ang main type of heat transfer sa loob ng Earth ay convection. Mula sa core, maaaring mag-transfer ang heat through conduction. Pagdating sa mantle, nagpo-flow ang heat dahil umaakit ang nainitan na molten rocks at bababa naman ang mas malamig na molten rocks. Ito rin ang dahilan ng paggalaw ng plates na pag-uusapan natin sa susunod na video lesson. Aside from high temperature, the Earth's interior also has high pressure. What is the effect of heat and pressure on pre-existing rocks on Earth? Let's talk about the next topic, which is metamorphism. Metamorphism means to change form. It's a process that leads to changes in the mineralogy, texture, and sometimes chemical composition of rocks. A pre-existing rock can be an igneous rock, a sedimentary rock, or another metamorphic rock. Kapag nabago ang environment ng isang pre-existing rock, pwedeng physically or chemically, hindi na gaya ng dati nitong environment kung saan ito na-form, mabubuo ang metamorphic rock. Ang metamorphism ay nakakabuo ng isang type ng rock na diniscuss sa previous lesson, ang metamorphic rock. May dalawang posibleng dahilan ng metamorphism. Una, heat. Pangalawa ay pressure. Sila ay tinatawag na mga agents of metamorphism. Heat is an important agent of metamorphism because it increases the rate of chemical reactions that may produce minerals different from those in the original rock. Pwedeng ang pre-existing rock ay mainitan o ma-applyan ng heat kapag malapit ito sa magma or lava. Or pwede ring dahil sa malalim na kinilalagyan ng pre-existing rock ay umiinit ito. Heat also causes a type of metamorphism which is called contact metamorphism. Sa contact metamorphism, yung mga pre-existing rock katulad ng shale, quartz, sandstone, and limestone ay naiinitan dahil sa pagiging malapit sa magma chamber. Kapag nainitan ng mga pre-existing rock na ito, maaaring magbago ang kanilang chemical composition at maging bagong type ng rock. Usually, ang mga metamorphic rocks na nabubuo dahil sa contact metamorphism ay walang lines or bands na tinatawag na foliation. Kung mapapansin natin sa picture, random ang pagkakaayos ng minerals. Halimbawa din ng limestone na kapag nag-metamorphose ay nagiging marble. Sandstone, nagiging quartzite. Kung mapapansin natin, walang lines or patterns sa rocks na ito, kaya ang tawag sa kanila ay non-foliated metamorphic rocks. Ang isa pang agent ng metamorphism ay ang pressure. Like temperature, pressure increases with depth as the thickness of the overlying rock increases. Buried rocks are subjected to confining pressure where forces are equally applied in all directions. As you go deeper, the pressure increases and also the temperature increases. Confining pressure causes the spaces between mineral grains to close, producing a more compact rock that has a greater density. Kung mapapansin natin sa figure na ito, noong una, medyo may space pa sa pagitan ng minerals sa rock na to, pero pagkatapos ma-applyan ng pressure, Nagdidikit-dikit na sila at wala ng space. So pressure causes the rocks to be more compact. At greater depths, confining pressure may cause minerals to recrystallize into new minerals that display a more compact crystalline form. Also, pressure can cause foliation or lines in metamorphic rocks. The term foliation refers to any nearly flat arrangement of mineral veins or structural features within a rock. It is a fundamental characteristic of rocks formed from regional metamorphism. Kaya usually kapag nabuo ang rock dahil sa regional metamorphism, may foliation yung metamorphic rocks. Regional metamorphism happens when deformations occur in larger areas. Katulad dito sa figure, dalawang malalaking plates ang nagbabanggaan o nagko-converge, kaya nade-deform yung nasa gitnang part. Nangyayari ang regional metamorphism sa malalaking geologic processes like mountain building. Usually, nagkakaroon ng regional metamorphism sa convergent plate boundaries kung saan nagbabanggaan ang dalawang plates. So, ano ang epekto ng heat at pressure sa pre-existing rocks? The rocks change their form and type. Look at the diagram here. From shale to slate to schist to gneiss, and it becomes migmatite. You can see foliations in all these metamorphic rocks at mas visible kapag mas mataas ang heat at pressure. Now let's try how much you have learned from our discussion. Get a piece of paper and try to answer this activity. All you need to do is tell whether the character talking is an expert in geology or an imposter. Write expert on your paper if you think he or she is telling a true statement, and write imposter if you think he or she is telling a false statement. Let's try the first one. He says, radioactive heat is produced by decaying radioactive elements found inside the Earth, like uranium-235 and uranium-238. Is he an expert or an imposter? Next, Earth's primordial heat does not affect the Earth's internal temperature. Is she an expert or an imposter? Metamorphic rocks formed by regional metamorphism are usually non-foliated. Is he an expert or an imposter? Metamorphic rocks formed by contact metamorphism are usually non-foliated. Is he an expert or an imposter? Radioactive half-life is the time required for half of the radioactive atoms present to decay. Is she an expert or an imposter? It's now time to check your answers. The first one is an expert. The second one is an imposter. The third one is another imposter. Number 4 is an expert. And lastly, number 5 is also an expert. Let's try to do this activity titled Classify Me. You are going to observe the physical characteristics of each of the metamorphic rocks shown. Give the type of metamorphism that formed the rock and the description of its texture, foliated or non-foliated. Let's try the first one. Gneiss. Second one is amphibolite. Third one is hornfels. Fourth one is quartzite. And the last is schist. Now let's check your answers. The type of metamorphism of gneiss is regional metamorphism. Its texture is foliated. The type of metamorphism of amphibolite is contact metamorphism, and its texture is non-foliated. The type of metamorphism of hornfels is contact metamorphism, and its texture is non-foliated. The type of metamorphism for quartzite is contact metamorphism, and the texture is non-foliated. Lastly, the type of metamorphism of schist is regional, and the texture is foliated. Now let's go to the summary of our lesson. Today you learned that there are two sources of Earth's internal heat, which are primordial heat and radioactive heat. Primordial heat is the heat from the accretion and bombardment of the Earth during its early stages of formation. Radioactive heat is the heat generated by long-term radioactive decay of uranium-235, uranium-238, thorium-232, and potassium-40 in Earth's crust and mantle. Also, you learn that metamorphism is a process that leads to changes in the mineralogy, texture, and sometimes chemical composition of rocks. The agents of metamorphism are heat and pressure. Contact metamorphism happens when heat from the magma or lava changes the physical and chemical environment of a pre-existing rock. It usually forms non-foliated metamorphic rocks. Regional metamorphism happens when deformations occur in larger areas. Congratulations! You are now done with lesson 4. See you in the next video lesson. Bye!